Good morning, afternoon, or evening, depending on your time zone. I am your host, Gaël Lebris, for this webinar on assessing the impact of climate change on airports. And before we start, just a couple of reminders. Number one, you should see somewhere on your screen a GoToWebinar window, and you have a field called Handouts, where you can download the material of this presentation. Still in the same window, number two, you should have a chat box where you can ask your questions during and after the presentation, and we will address your questions right after the presentation. I would like to start with some acknowledgements. This initiative, this research project, is funded through a WSP USA Research and Innovation Fellowship. And we would like to thank all the leadership of this WSP USA Research Innovation Fellowship program for selecting our research idea and also for all their support during the project. And I would like also to thank the broader community of experts of WSP all around the world who have contributed to this project and are still contributing to the development of this toolbox, which is truly a collaborative effort. The research team for this project, myself, Gaël Lebris, a senior aviation planner and senior technical principal with WSP in the USA. I am the principal investigator for this research, and I was assisted by my deputy, Lu Jiang Nguyen. We are both based in North Carolina, United States of America. So the goal of this research project was really to address that question. How can we assess the local impact of climate change on airports? And this research effort aims to identify the domains, assets, items that are exposed to climate change, identify the climate-sensitive critical parameters that are driving these different domains or assets, document the impact of climate change on these parameters, and research, unveil and address, when possible, the gaps in current standards and practices. And the expected deliverables are a guidebook or toolbox for supporting the WSP community, and articles and research papers for sharing the main findings of this research project with the aviation community. So before we present our findings and describe our methodology, just a reminder on climate change. Greenhouse gas emissions have been reshaping the global climate since the mid-20s. And it's not only about trends and figures and models, it's also about concrete effects in the real world. And in particular, what we can notice is the increase, significant increase in what we could call climate anomalies, extreme weather events that individually, of course, it's always hard to explain them directly and uniquely with climate change, but all together, they show a pattern, an increase of extreme weather events that can be explained altogether because of climate change. And I invite you in particular, if you want to know more about these climate anomalies, to go on the website of the US NOAA, and there is a hyperlink in the PDF version of that presentation available for download in the GoToWebinar window. As you know, the UN IPCC predicts a likely increase of plus 1.5 Celsius of the global mean surface temperature by 2040, and both this increase of anomalies and of the ground temperature, they have been confirmed by independent bodies. And in the US, there is this intergovernmental and interagency effort called the USGCRP, and also the National Academies of Science, Engineering and Medicine in Washington, D.C. So climate change is already here, and it will worsen over the coming decades, regardless, actually, the scenario in terms of decrease of our emissions, because decreasing the emissions means that we are still emitting. And the focus of this webinar is climate resilience. So we are not going to address the impact of aviation on climate change per se, but just a reminder, aviation altogether is about 2% of the GHG emissions in CO2 equivalent, and it's about 3.5% of the total impact, total effect of climate change from human origin. And aviation has been very proactive in trying to reduce its footprint in terms of emission, but also the overall environmental footprint of aviation, and has worked, since decades on that, and has been pretty successful actually so far. So why is this a threat to airports? As you know, the local climate is a significant influencer of airport operations. And a changing climate can impact, for instance, performance and resilience. One of the effects of climate change, is global warming. And when you have global warming, it means that you have more very hot days. And during these very hot days, it's not only the average temperature, but you have an increased number of days with extreme hot temperatures. It's going to have potentially an impact on the payload and the range of the aircraft that are going to take off from your airport based on the runway lengths available. And at some point, when you have too much of a limitation of the payload and range, well, some flights might have to be canceled. And it's what happened actually, for instance, at Phoenix Sky Harbor International Airport in 2017, where in a single day, 50 flights were canceled because of the extreme heat, I can also mention, the winter season 2010 in Europe that was, with extreme snowstorms, as never seen before, and that has triggered significant investments not only in winter operations equipment, but also the upgrade of aircraft de-icing systems and of winter operations management in general all across Europe. And something similar happened a couple of years later in North America. Changing climate is also a challenge for airport assets. And for instance, this is extremely visible, in the Arctic regions, such as Greenland and Alaska, where you have the permafrost. Because of the warming of the local climate, well, it's not going to be anymore perm or frost. You're going to have a loss of consistency of the permafrost. And for instance, you have this airport in Greenland that I am mentioning on the slide right now that might close to most commercial traffic in 2024 due to the loss of consistency of the permafrost. And we will have also more frequent and intense extreme weather events threatening aviation facilities. Remember 2018, Typhoon Jebi in Japan, it cost $75 million to the Kansai International Airport to repair the damage due to the hurricane. And the airport is elevating its main runway, the entire runway is being elevated and further rising its seawall, You want to talk about other regions of the world? A couple of years ago, Brazil experienced its very first hurricane in the history of South America. The first hurricane recorded in South America. That's a big deal. So yes, aviation facilities will face the consequences of climate change, and they should assess their exposure to climate change and enhance their resilience as far as practicable. So this is an overview of all the different domains, assets, technical disciplines, and so on that we are covering in the toolbox. And of course, you might say that it's not completely comprehensive, it's missing some items, maybe, I will agree with you, but of course, we have limited time and budget, and what we did is focusing on the domains where we know that there is a gap in current practices or methodology, or domains where we should work on raising awareness on the impact of climate change, specifically on these items. And here is the overall approach that we followed for each one of these items. And I'm not going to describe everything, but what you can see, there is a blend of analytics, quantitative approach, trying to model, to define methodologies and so on, and let's say good discussions from the field. And for instance, we will talk about runway length requirements later during this presentation. As you know, the methodology itself is quite simple, but the problem is not that simple. The way you are going to use the output of your runway length requirement assessment, and how you're going to interpret all the different findings, for instance. So this is what we are trying to do here, combining together the quantitative approach and the, let's say, qualitative expertise. So through this toolbox, as I said, we have a lot of different discussions, and in particular on emerging climate-related issues in aviation, such as climate adaptation scenarios, and that includes potential retreat that is still a bit taboo in aviation, but at some point, if you have, for instance, a significant exposure to the high tide because of the rise of the sea level, or this kind of very hard constraint, at some point, maybe it's not interesting from a cost-benefit perspective to keep, the airport resilient, and maybe some airports might have to be abandoned, in order to be relocated elsewhere. But also climate justice, the increased need for real-time collaboration and new aviation energy vectors, new fuels, new mobility, etc. Just name it. We try to be comprehensive, regarding these different qualitative discussions. And also, we have developed a very innovative research work. For instance, the long-term trends on runway length requirements for jet aircraft for planning purpose that we are going to talk more about in a couple of slides. Developing annual forecast indicators and trying to model the effect of climate change on the aircraft de-icing activity, and that's very innovative so far. There is no such indicators. Some guidance for enhancing airport operational resilience facing climate change. So here we're not talking about infrastructure, we're really talking about organizations and operations, how to make them more resilient facing climate change. And I would like to mention, it's not a research and innovation project per se, it's a project we did for the Transportation Research Board in the United States, ACRP 1027 on ACDM. The link is in the presentation. The toolbox will be available most likely beginning of next year. And, we talked about climate change, more frequent extreme weather events is going to increase the need for real-time collaboration and tactical collaboration between the stakeholders, and ACDM is the way to do it. And here is our case study on runway length requirements. You might be aware of the general methodology for assessing runway length requirements and especially takeoff length requirements. Typically what you do, especially for a large commercial service aircraft, you start from these takeoff and landing performance charts provided by the aircraft manufacturers through these manuals called ACAP or airport planning manuals, depending on the manufacturer. And based on that, you do a graphical resolution of your problem. The FAA in the United States recommends these methodologies through Advisory Circular 150, 5325 for B, especially again for jet aircraft. And what we did is that we enhanced these charts to estimate the runway length requirements for different takeoff weight, in combination of range and fuel, what you see right now on the right of your screen. But moreover, as part of this research project, we developed guidance for computing runway length requirements based on future air temperatures, considering climate change, instead of the maximum daily mean temperature, MDMT, which is recommended for these assessments, and because it's calculated from past observations. So it doesn't necessarily account for climate change, but most importantly, it doesn't depict the future climate at your airport at plus 10, 20 years or more. So current industry practices can be adapted to determine future requirements. And this is an example, an assessment that we did for San Antonio International Airport in Texas, United States, as part of the strategic development program of the airport. What we did is that as part of the update of the master plan, we computed route and market specific runway length requirements based on the MDMT. So this is the standard methodology. And then based on their forecast, developed as part of the City of San Antonio Climate Ready Plan, the forecast on the summer daily mean temperature, which is a concept slightly different than the MDMT, but that we can use for replacing the MDMT for the purpose of this high-level assessment. Well, we projected the runway length requirements for the very long-term planning purpose, beyond the traditional 20-year horizon of the FAA methodology. And if you want to read more about this approach, you can read the draft Airport Master Plan chapter for facility requirements available on the website of SAT. And again, there is a hyperlink in the PDF version of this presentation. And as you can see on the bottom right, what we see is that at the 2070 horizon, if you do not take into consideration climate change, well, you might be missing 200 to 350 feet of runway length in your assessment. And if you translate that in terms of range for a 787-9, which was the critical aircraft of that assessment, we are talking about 500 nautical miles. So that can be a lot when you are trying to reach out to specific markets. And then, San Antonio is going to have, as I said, a new critical aircraft in the future, new long-range routes, etc. Now, the question is, if you are an airport that is not going to change, let's say, category of routes, of aircraft, and so on, and that's typically the case for large hub airports. They're already accommodating all the aircraft types possible. So when you have a kind of homogeneity of the aircraft market through time at the specific airport, can we come up with some trends, some equations for accounting for the continued improvement of aircraft performances through technological enhancements? And it's what we try to do through our research project. What we did is that we developed models for each aircraft market segment or category of aircraft and routes. And our equations feature corrections for accounting for the most demanding aircraft and also the lifespan of these aircraft. Because if you look at our model for all the aircraft types together on the right part of the screen, you see that we are basing our model on the first year in service, the EIS, entry into service. And of course, when you talk about runway length requirements, it's not so much about the EIS, it's more about how long these aircraft are going to be significant at my airport. So in our equations, we have a lot of caveats, and more of caveats, actually, we have variables, specific variables for taking into consideration the specific lifespan of the blend of aircraft types we are considering in your region or at your airport, And these models, again, they assume that we have the same kind of aircraft technologies, and that includes supersonic aircraft. You see on the graphic right now, we have Concorde, we have the Boom Overture that should fly in the coming years. But we do not account for things that do not exist yet or that we cannot have quantitative data yet. And I'm talking about all these technologies that could have an impact on the aerodynamic performance and ultimately the takeoff and landing performance of aircraft. Thinking about electric propulsion, hydrogen aircraft, and you can use liquid hydrogen for powering fuel cells, but also to be burned directly into engines as a fuel, and also innovative configurations, thinking about the flying wings, the very high, ratio wing, and so on, that at some point might modify the overall trend. So these equations, you might not want to take them for consideration beyond 2070 or 2100, depending on the region of the world. So these equations are not for design purpose, I repeat, do not use them for design purpose, but they can feed high-level strategic discussions. When you are an airport, again, a larger airport with all the aircraft possible, or you have an homogeneous set of aircraft types, you're not going to change market in the coming 10, 20, 30, 50 years. And you see that your runway length requirements are increasing because of climate change or other factors, you might think, hey, if your airport is extremely constrained, if you have very hard constraints beyond the runway end, you might think, is it still worthy, to expand my runway that much, And on the final, tuning of your decision making, these trends can be used, for discussion purpose, considering again the very long-term horizon. And that's it for this presentation. Some of you sent me questions before the webinar about the risk assessment. I'm not going to enter into details today because that could be an entire webinar by itself. I'm just providing you in appendix of the handout a sample of the risk assessment matrix that we are recommending for use for these assessments, and also discussion on the risk likelihood. And what I want you to remember from this slide is not necessarily all the thresholds. It's more that these scales of likelihood or severity, at some point they should be adapted, tailored to individual airports. It depends on the domain that you are considering. Is it safety, security, environment, financial, operational risks? And it's also about the strategy of the airports. What do you want to cover, and how far do you want to protect yourself against specific risks? So there is a big work of preparation with the local airport community and the stakeholders as well, as far as practicable, to develop scales that are adapted to specific airports. And we are at the end of the presentation itself. Here you have my contact information if you have questions. But now it's time for your questions, the one that you typed in the chat box.
Thank you, Gael, for a great presentation. So before moving into the Q&A period, I would like to remind attendees to enter your questions in the question box on the GoToWebinar platform, and also you can download the PDF version of the presentation from the handout box on the dashboard. So we received some questions upon registration. Thank you for entering those. Let's start with the first one. Can you please elaborate a bit more about the decarbonization best practices?
Okay, so I mean, again, decarbonization and the reduction of the climate footprint of aviation is not the focus of this presentation. What I can say is that airports and aviation, world aviation community have developed together, a lot of ingenious strategies for decreasing, for decarbonizing, airports. I can mention, for instance, the electrification of the fleet of GSE equipment. I could talk also about the recycling in place of asphalt, on both the land side and air side during rehabilitation. We can talk about circular or quasi-circular strategies in terms of waste management and water management, and also about microgrid at airports, as long as, of course, they are based on renewable energies. If you want to know more about that topic, I invite you to download our white paper number 10 on sustainability and airport citizens of the future of airports, a vision of 2040 and 2070 on the website of ENAC alumni, ENAC alumni, and you have, we put a lot of references to industry roadmaps and documents specifically on the decarbonization of our industry.
Thank you. Next question. What are the consequences of climate change in safety flight, takeoff and landing?
Yeah, that's a very interesting question. And it's not that easy to answer, actually, because there are all kinds of potential impacts of climate change on flight safety, depending on the region and the specific consequences of climate change locally. One impact that I see is about, everything about runway friction, runway adherence. if we have an increase of the extreme weather events, more storms, more snowstorms, maybe more violent, freezing events, we might want to be more robust in terms of runway friction coefficient measurements and reporting. And although we could talk about the health, and the robustness of the adherence properties of the surface course of the runway, especially the macro texture and the drainage. With climate change, assets will be challenged, and the mechanical properties of the surface course of the runway has to be maintained as well, and that could be challenging in the future, So it's not one single parameter, it's all about everything that could challenge runway friction, and the good news is that the industry has done a tremendous job over the past years in being more resilient on that matter. A lot of education to the operations community and the pilot community about what is runway friction, the global, the GRF, the global report, the global runway friction effort of ICAO. And also, we have a lot of countries and airports. They have done a tremendous job in considering that issue, not only, again, from a reporting aspect or a runway pavement aspect, but altogether, runway pavement, reporting, knowledge of the pilots and airport operations people, but also checking that the runway strip, the runway end safety areas, what we call runway safety areas altogether in the US, are compliant with the standards and recommendations of ICAO,
Thank you. Next question. Did you assess impacts of wind and changes in wind direction as a climate parameter?
We did not develop a specific model, but we have a discussion about that matter because that's a very good question. We could expect at some locations a long-term change in the wind rows. And that could be very impactful, especially at airports with a bit of exotic procedures, for instance, when because of obstacles or noise mitigation procedures, you take off and land on the same side of the runway, what is called, for instance, sod props. And so if you realize that you have a change in your wind direction, your operations might be endangered, And although, of course, we could talk about crosswind, in the future of crosswind, especially for crosswind sensitive aircraft, light aircraft. I do not necessarily have the answer, but we are documenting in our toolbox research papers and discussions on the matter.
Thank you. Next question. Did you consider integrating Future Ready and how?
Yes. And how? I would say the whole research project is about being future ready, right? It's about bringing more resilience into our projects, considering the impact of climate change. One of our main focus in that book of methodology and this toolbox is that we want our experts, our engineers, our planners, our specialists, to, when they think about designing and planning, to take into consideration elements of climate change, to make sure that what they are designing is not only compliant with the standards and the expectation of the client, but they can have this discussion, maybe going beyond and saying, hey, climate is changing. You might have these extra exposures that you are not necessarily aware today. What about taking them into consideration? See what I mean? And that's typically the philosophy of the WSP Future Ready initiative.
Thank you. We'll take the last question. There are additional questions which will be followed up directly by Gail. What can be the best practice approach to justify long-term investments on development of mid-sized sea-level airport, taking into consideration facing sea level rise?
Yeah, okay, that's a hard question, especially because, again, you see one airport, you saw one airport, right? What I can say is that, again, it's going to depend on the airport itself, but coastal areas are going to be exposed to the rise of the sea level, you know. And it's not only the average sea level, of course. It's about, for instance, you know, the high tide, potential storms that are going to create surge. And for instance, you know, you have airports that are on reclaimed land. They can be particularly exposed, you know, to these risks, you know, especially if, for instance, along with the airport, you have a river that itself is flooding. And you might say that sounds like a bad scenario for you know, a cheap movie, but actually some airports, they have all of that together at the same time. And recently, the airport of Nice, for instance, in France, got partially flooded, you know, because of the simultaneous event of river flooding and storm and so on, you know. Everything said, again, you know, it will depend on individual airports. What I can say is that for your cost-benefit analysis, you definitely have to take into consideration climate change and potential extreme weather events. And based on that, well, you have different strategies in front of you that are going to feed your cost-benefit analysis. Is it about making your airport resilient and robust to the next storm that you might have? Is it about building a seawall around your airport? Is it about maybe retreating from part of the airport? You know, maybe you have 2 runways on each side of the airport. Maybe you abandon one at some point and build a new one further. And maybe some smaller airports, you know, extremely exposed to these risks. Well, maybe some of them might be abandoned and rebuilt as they were, because at some point maybe it will not make sense anymore to try to make them more resilient from a cost-benefit perspective. But again, it's a complex problem. You have to take into consideration, you know, airport issues, local specificities, and of course, the community around the existing and potential future airport as well.
Thank you, Gail. So we're at the end of our webinar session. Please feel free to follow up directly with Gail via the contact details shown on the screen. And I would like to thank all attendees for joining today, and big thank you, Gail, for a great presentation.
Thank you.